So simplify this complex number. It's a complex number divided by another one. We can simplify this. I probably should start with a simpler case first. Let's just consider this. Let's say that I've got 3 plus I over, we'll just say 2I. Well, again, the problem with this expression is I've got a radical in my denominator. And when we were looking at radical or irrational numbers earlier, we know that we simplified form, we don't like to have radical expressions left in our denominator. So I'm going to multiply this this fraction, this ratio, by I over I. Now, when I do that, the numerator becomes 3I plus an I squared. My denominator becomes 2I squared. Now, because I squared equals -1, right, I can change this further to 3I minus 1 over 2 times -1, which is the number -2. So probably the best form to write this number would be, it would be -1 plus 3I all over the number -2. So that's how I simplify this complex number, right? Multiply by I over I to get the complex number, to get the imaginary part out of your denominator. Now we turn our attention back to the problem that's on this page, and in order to get rid of the complex number that's in this denominator, we're going to multiply this by the complex conjugate. I would form the complex conjugate of this denominator by simply writing 2, the real part is 2 plus 3I. So this denominator has a complex conjugate of 3 plus 2I. Now in the numerator, I'm also going to multiply by 2 plus 3I. The reason why I do that is this is going to get rid of all the imaginary parts in my denominator. And it's going to change the imaginary parts in my numerator. So let's go ahead and take a look at the denominator first. And again, we're multiplying these two binomials, right? Real part, imaginary part, if you will. First times first is a 4. And then if I continue, I would have a plus 3I. That's my outside product. And then I would have a, no, I wouldn't either. I would have a, sorry, let me write this for you. I'm going to do this, and then I'm going to do this. So the first part there is 2 times 2 is 4, and then I have a plus 6I. Okay, now I need to do the same thing for the second part here, the imaginary part. I'm going to multiply this times each one of these. So I have a -3I times 2, which is a minus 6I. And then I have a -3I times positive 3I, which is a -3I squared. Now, if I simplify that, right, the first thing I notice is that I have a 6I and a -6I, which will cancel out. So this denominator becomes 4 minus 3I squared. I squared equals -1, so this is 3 times -1. So what I'm looking at in my denominator is 4 plus 3, or the number 7. So in my answer, I'm going to have a 7 in my denominator. Right? Now, let's take a look at what's happening with this numerator. I'm going to come down here and look at them in this part. So for this numerator, I'm going to be multiplying 3 plus I, and then I'm going to be multiplying 2 plus 3I. I just basically have to see where this is going to take us. 3 times 2 is 6, and then 3 times 3I is plus 9I, and I times 2 is plus 2I, and I times 3I is plus 3I squared. Well, this I squared is -1, so this is a plus 3 times -1, or minus 3. When I combine that with the 6 that's right here, that's going to give me a 3, right? 6 minus 3 is 3. So I'm going to have a 3 for my real part. For my imaginary part, I'm just going to combine my 9I and my 2I, which is a plus 11I. So the final simplified form here is 3 plus 11i all over 7.